Welcome to Data Protection Gumbo, episode 22, and I am Demetrius Malbro, your Chief Data Protection Chef. And Data Protection Gumbo is set up with the aim to expand the awareness of the IT industry by being a voice for protecting all types of digital information. And today I am hosting our very first debate, and the rules are similar to boxing, which means you cannot hit below the belt, hold, trip, kick, headbutt, wrestle, bite, spit on, or push your opponent. Now, in the red corner, standing by the 5 pillars of tape management, asset management, chain of custody, library management, disaster recovery, and quality control, the tape whisperer and CEO of GizallaByte, Gerard Nicol. And in the blue corner, float like a butterfly, light as a feather, due to his virtualization skills in VMware and also disaster recovery as a service, technology strategist with NetVPro, Paul Berndt. So gentlemen, your topic today will be, is it safe to go completely tapeless, i.e. tape versus disk? So also try to stay within the context of economics, reliability, and manageability. So, go to your separate corners, and let's get ready to rumble. Alright, I hope that's a great impression of the guy. So let's go ahead and start off with you, Gerard.
Well, good morning, guys. It's an interesting set of rules. I thought this was going to be something more like ultimate fighting. Which seems to be the flavour of these discussions when they're had on LinkedIn. Basically, you know, I think the topic is a very complicated one, and it really sort of comes down to personal choice, and also I think how you use the respective technology that you're deploying. Now, conceptually, tape or disk can be used like tape. They're tape and disk are very similar technologies, just adapted differently. They're optimized for one way of being used over another. So you can use a disk just like a tape if you want. Conceptually, you can use a tape like a disk. And with technologies like LTFS, that is starting to occur. But really, to use tape completely like disk or to replace disk would be an absurdity. Similarly, to use disk like a tape would probably be quite absurd as well. So, really, I think to consider whether or not you can go completely tapeless or whether that's a responsible thing to do, I think has to do with so many other factors, like, you know, how you deploy that disk before you can really kind of make a call on whether or not that is a sound thing to do or not. So that's my opening punch.
All right. Paul, okay. Are you stunned?
Yeah, he was quite above the belt with a lot of that response. Like you said, it's not ultimate fighting yet. So, you know, in the business that I'm in, you know, we're all about real-time data and, you know, what the most current version is, and we're not too worried about the older version. Now, obviously, you know, versioning is important because, you know, you got a lot of end users out there that will go ahead and delete files, you know, accidentally, on purpose, and that kind of thing. So, obviously, you know, when you want to do your disk-to-disk backup, you're also including versioning with that, so you can go back, you know, a day, a week, you know, in this day and age, you know, we're getting a lot different kind of attacks, crypto locker to name one, because now people are holding your actual data hostage, and we need to find the best way to combat that. Obviously, on the security is a whole nother aspect of data protection.
Right.
But to me, it's all about how quickly we can go back to the latest, safest version, and I think disk is the best way to do that, especially with the seek times that you have with tape.
Gerard, he mentioned seek time. What's going on with that?
Well, I think really it kind of comes down to what it is you're looking for and what compromises you have to make along the way. So, ideally, I think everyone should have, a copy of the most recent data on disk. It really comes down to what you do when you make the call of having to make that compromise. So, ideally, if you've got enough disk to spare and you can afford it, you can have as many versions of a backup as you like on disk. And if you look at technologies like Microsoft Windows, for the last probably 6 or 7 years, Microsoft Windows has had, previous version support in natively in Windows. So if you're looking at unstructured data like pictures, for instance, or Word documents, that you can turn versioning on so that as you make different copies of the Word document, Windows will automatically retain those previous versions for you. On a more sort of structured basis, technologies like open technologies like Git can be used for things like programming source, where you can make changes to the software, and once you're happy with the change, you can push that change up, and the versioning will occur. They're all disk-based technologies, and they're all kind of commonly used by people. Now the big problem comes when you start running out of disk. So if you're running on your laptop, and I've got a Microsoft Surface which has got, I think, 256 gig of memory. After a while, you start running out of space, and the call is then, what am I going to have to cull to fit all of this stuff in the scope of the current disk that I have? And that's when people start looking at archiving data off. And they also look at just purging data altogether. So when you talk about seek times on disk compared to tape, obviously it really relates to what you're restoring. If you're on disk and you're restoring a whole system, then there's a whole lot of seeking that goes on under the covers on that disk to get from one file to the next. And if you're implementing things like deduplication or delta level backup, then really the disk could be freaking out, going all over the place, and that can be quite slow. Whereas on a tape, to restore a full system, technically you're not doing any seeking. You're starting at the front of the tape, working your way back to the end of the tape, working your way back to the front, as you kind of snake back and forth to restore all of that data. So if you're restoring large quantities of data, and all of those quantities of data are sequentially written on the disk, then really seek time is not an issue on tape at all, where it could be potentially a big problem on disk. So once again, it really comes down to what it is that you're restoring. Even if you're restoring a single file off a tape, if that file is the first file on the tape, then you've got no seeking going on. But you do have, mount time and things like that. So once again, it really comes down to what it is you're restoring on a given day, and what kind of recovery you're participating in.
All right, guys, I got a quick scenario. You're throwing around file types and file sizes. So, quick scenario. Millions of files, millions of small files, right? That are stored on a tape versus stored on a disk. What are your thoughts? Paul?
Millions of files, that kind of goes into a whole nother realm of, nowadays people are doing object storage for millions of files. Not, the straight standard file system, NFS, let's just say. So, what I'm saying is when you're going that size of data, that amount of data, we're going to store it differently than what people traditionally would think it is in NFS type file system. So, with that kind of thing, we're looking at, more of a redundant global solution, multiple data centers backing up each other. So in reality, you're not going to be, trying to push a bunch of data back. That's my response.
Okay, Gerard?
Well, I think it's hard to respond to that. That, I think, one of the things that I've, come to realize over the years of being involved in backup is how nobody does it exactly the same way. So just in my specialist niche of tape management, when people contact me to look at buying a tape management software, everybody presumes that the way that they do tape management is exactly the way that everybody else does tape management. And so they expect that when they're buying my software, that my software will do out of the box exactly what it is that they do with their tape management. Now, it took me a long time to provide people with a solution that does everything that they want, but 90% of my software caters for the differences between how different people manage their backup tapes. So there's probably a good 80% of commonality in how people manage their backup tapes, but that 20% of difference between every customer, and no customer is exactly the same, accounts for about 90% of the code that I've had to write into my product. Now, a lot of the reasoning behind the different ways people manage their tapes has to do with the different ways that people back up to tape. Because everybody kind of implements backup slightly differently as well. Now, the same thing goes for restore. That, some people have, their disaster recovery system is they have a single computer, they back it up to tape, someone comes and picks it up, takes it off site, and if they have a disaster, they're calling the offsite company. Hopefully the offsite company can find all of their tapes, and then in the middle of the night, they drop all of those tapes back to a second location and start restoring from tape. Now, there are other people who don't even go that far. There are people who back up to tape with no disaster recovery site. Their hope is that, if there's ever a disaster, they might be able to find or, negotiate a computer somewhere and restore. Then there are other people who have, 3 data centers around the country, and those data centers replicate to each other. Now, importantly, you've got to understand that replication is not backup. A lot of people consider replication to be backup, and I suppose in a way it's a form of backup if you consider backup to be redundancy. But no one thinks RAID disk is backup. So if you've got got a RAID disk array, everybody just looks at that array as one disk. Whereas in fact it could be several disks, and each of those disks are backing each other up, but no one considers that to be a backup. Now, if someone's replicating their mainframe or replicating a database from one one site to another, there's a lot of people out there who would call that backup. There's no backup version there. If one of those systems got corrupted, it would corrupt the other system. But for a lot of people, they're quite happy to get rid of all backup and just rely on their high availability. And you know, just in discussing that, I've discussed 3 or 4 flavors already. Add to that an infinite number of flavors of how people are doing their backup and how people are doing their restores. So to kind of generally, you know, say whether or not something will or won't work, you almost need to look at it from an individual's perspective of whether that will work for them. And you also have to take into account that, you know, no matter what it is you do, there's always a possibility that it won't work. No matter how much you test things, you know, you can never really foresee every solution, every possibility that might come your way. And in a way, that to me is one of the strengths of tape. The strength of tape is that as long as you have a valid backup to start off with, taking that backup off-site and putting it in someone else's hands, as long as those people are competently managing that data, always gives you that opportunity to get those tapes back and kind of start from scratch. Whereas when you've got data which is spun up and accessible, even if that data is between firewalls and protected by different technologies, you'd be surprised how few these technologies are actually built upon. So if you go back to the core of it, you find a lot of these appliances run open source software or have web interfaces that are kind of built on the same code bases. So if you're backing up a mainframe to an appliance and that appliance is running Linux, chances are that Linux is easier to hack into than the mainframe is. So if you're backing up to that appliance and, you know, a hacker does manage to get into your network, chances are they're going to compromise your backup before they compromise the primary data. So if they have compromised the backup and then they compromise your primary data, you got nothing to go back to. Whereas if the tape is physically offline and stored competently, you've always got something that, you know, you can fall back on as a last resort.
Well, and Gerard, I'm going to jump in here a bit and kind of break this up a little bit. And Paul, I think he kind of knocked you down on the mat a little bit, so I'm going to start counting here so you can get back up. Now, he mentioned manageability, so I'm sure you have something to say about, you know, the manageability of tape and handling tapes, you know, versus disk. So go right ahead.
Yeah, in our industry, and I'll start off with, you know, counterpunching on the DR piece. I'll go ahead and agree with Gerard on, you know, replication is not backup. It is just another copy of your data. And you're correct. You know, many times if it gets corrupted, it'll just corrupt both sites. I'll jump back onto the manageability of it all. You know, we feel that less moving parts is more streamlined. So, you know, if we set up a backup off-site onto disk, then, you know, you don't have, you know, the truck time, the watching of the tapes, you know, making sure where things are at. You know, we know where it's at. It's at the DR site or, you know, backup site, you know, and it's all in how you put the data out there. We support both ways. Most of our customers choose disaster recovery because they have a backup solution on site. But some customers actually choose both. So they push a copy, a live copy for DR, you know, replication live as fast as soon as the changes they get they're pushing changes off to our site. And they also push their backups, versioning to us, depending on how many versions they want, obviously that takes more space and it costs them more money. And now we're getting into, the whole cost thing, because nowadays, disk becomes cheaper and cheaper. I mean, they have 10 terabyte drives out nowadays. So it comes to, hey, it's just really inexpensive nowadays to manage, disk locally and in the cloud. There's a lot of solutions out there that are very inexpensive, using the cloud.
Okay.
Well, in response to that, this is an interesting. It's an interesting argument of people who advocate going diskless, going tapeless, and that is that it is quite true to say that disk technologies get cheaper and cheaper, but at the same time, also tape technologies get cheaper and cheaper. So it's not as if one technology stands still while disk, like it's not as if everyone deliberately holds everything else back or stops working on it because people are making advances in disk technology. The same thing goes for network connectivity as well, because a lot of the backup solutions that people sell are highly dependent on network bandwidth. That I've been having this discussion with people for a decade, and basically the premise of their argument is that bandwidth is just going to continue to increase, and disk is going to continue to get cheaper. But what they don't address in that is that, like anyone, when they're building a highway, as soon as you build a highway, okay, everyone gets that nice, honeymoon period the day the highway opens where, they get to work 20 minutes earlier. But, everyone knows that 6 months later they're going to be in the same traffic that they were in, 6 months before. So now you've got a 10-lane highway rather than a 6-lane, but the 10-lane highway is moving at the speed that the 6-lane highway was. And that's the bandwidth analogy. But also with disk, that as soon as you increase the capacity of that disk, people find ways of filling that disk. Now, the more disk that you fill, as long as tape remains proportionately less expensive than disk, the more disk you have, proportionately, the more savings you get out of tape. So if you had 10 terabytes of disk last week, and you have 100 terabytes of disk next week, then you've got 10 times more disk, and as long as tape remains 4 or 5 times cheaper than disk, tape has just become more attractive, not less attractive, as disk becomes less expensive and is utilized more.
Wow, that's a really good argument. I will take that in very good consideration. But yeah, on the bandwidth piece of things, I mean, that's part of our calculation that we have to do with every customer is, one, figure out, most people know what their download speeds are, but it really comes down to, for us, pushing data off-site is their upload speeds. And most people don't know what their upload speeds are. So first off, we calculate what their upload speeds are, and then we can do the theoretical, how much data can we push off-site, and then we use their backup solution to calculate how much the difference of their change rate. And a lot of people don't even know what their change rate is. So, we're doing a lot of educating in this market to figure out, hey, is it feasible to push your data off-site in fairly, at least once a night to get a DR site halfway reasonable that makes sense. Otherwise, you're right. I mean, they're going to have to roll trucks, either push it to a portable drive and send it that way, or stay on their existing tape.
So, reliability. So disk is definitely more reliable, right?
Then what?
Than tape.
You know,
is that true, Gerard?
Well, no one ever implemented a RAID solution for tape. So, you know, at its core level, if you look at what a disk drive is you know, a disk drive has all its eggs in one basket. So you've got, you know, the disk, you've got the motor, you've got the heads, you've got the computer interface, you know, the controller. It's all built into one device. Now, that's a whole lot of technology that can go wrong in the one place. And that's why, you know, disks are firstly, you know, normally used now in an array of RAID disks, so that you might have 3 or 4 disks in a RAID array, and if one goes out, then, you know, someone has to go and replace that disk, and that, you know, that will dynamically rebuild. But, you know, from an individual unit perspective, tape is a lot more reliable than disk is, but the way that disk is used, obviously stored in, you know, in arrays, then those arrays can be, you know, as reliable, if not more reliable, than an individual tape. But in a way, it's kind of like not a fair fight, because you're comparing 3 disks to 1 tape. So, you know, if this was a boxing match, you know, to say, well, look, Gerard, you're 1 tape, but we're going to put you up against 3 disks, well, that's kind of not a fair fight. That, you know, if I had 3 tape drives that were writing in parallel, I can start doing a whole lot of creative things with those 3 tape drives. I could reduce seek time by having 3 copies of data and designing systems that say, okay, every time we write data out to tape, we're going to write it out to 3 tape drives. And by the way, we're going to have a 1-to-1 marriage between the tape and the drive. So we're going to have the drive, you know, the motor, the controller, and the media all in one place. They're going to always be one and the same, and I'm going to have 3 of them. Now, if I start streaming data out to those 3 drives, and I need to do 3 individual restores, and those 3 individual restores are in 3 different parts of the tape, maybe I could design software that kept each of the tapes positioned a third of respective third of the way into those tapes, so that when someone wanted one of the files, it would go to the tape drive which was most conveniently positioned to get that data. Now, that's a ridiculous proposition, because that's just not how tape is used. You know, that's starting to use tape like people use disk. Now, even if I wanted to do that, I'd have to design my own backup systems and my own mechanisms. I'm not going to do that. It's just, no one's done it for a good reason, and the good reason is that that's just not how people use tape. So, if you want to just talk about, you know, parity of reliability, if I had a single disk that was just sitting there by itself, and it was online and it was in use, and I had a single tape which was in use, I'd much rather rely on the tape than I would the disk from a reliability perspective. Now, and that's also saying that the tape is you know, permanently stuck in the tape drive. Because, you know,
which happens pretty often.
Well, it's that also, I think, is a bit of a myth too. But we can talk about that later. But if there was, let's just say, you know, you want to compare the technologies like for like, you could design a tape drive that didn't come in cartridge form, that was just, you know, tape that was permanently in the tape drive. Well, it's not going to get stuck in the drive because it's designed to permanently be there. So, you know, with a disk drive, someone gets the disk drive and they get a screwdriver out and they permanently bolt that disk drive into the system. Well, you know, obviously tape is designed differently. It's designed to be, you know, one to many. You've got one tape drive, and for every one tape drive, companies often have 1,000 different tapes. So, I use the word promiscuous. Tape drives are designed to be a lot more promiscuous than a disk drive is. So, if once you take into account the differing way tape is used, so the fact that one tape drive has a relationship with 1,000 different tapes, and that those tapes are then ejected, often sent to on-site racking for deep archive, or sent off to an off-site vendor, and then stored in racking there, and then brought back and reused. If you use disk the same way, then I think you'd probably find that, both technologies would be reliable, but I'd have a much better feeling of being able to get the data back off the tape than I would off the disk if you were using disk exactly like you used it like tape.
All right, gentlemen, so we are moving into the final round here, and closing arguments. Paul.
Oh, closing arguments. Well, I was just ready to rebuttal his whole
sure.
tape thing. Well, part of the problem with what I've seen with tape drives in itself is, like you said, they're promiscuous, and the drives themselves have to read and write through a lot of different disks. So then, now you're like, okay, the drive becomes worn, and you have to calibrate that drive to make sure it maintains, the right read-write speed of the tape. And let alone that, now, you talked about archive. You archive that off, but, you want to move it forward with your technology. You want to move from LTO5 to LTO7, and, I stored a whole bunch of LTO4 drive tapes in my data center, in my offsite archival. So how do I go back? Because many different manufacturers only support 2 versions back of your LTO drives themselves. So now we're like, okay, do we have to maintain that old drive in order to make sure we can read the old LTO4 systems?
Well, I think there's an easy answer to that, and that is that as data becomes older, no matter what technology you use to back up that data, as it becomes older, it becomes harder to read once you've even got it back to disk. So, if you had data from, a Microsoft Exchange from 2 weeks ago, you've got the same version of Microsoft Exchange today, and, if you need to restore, that's pretty simple. But even if you had a local copy of a Microsoft Exchange data store from 10 years ago, your challenge really isn't how you get the data back to a position where you can start, using it in software. The real challenge is being able to interpret that data 10 years down the track. So, as data ages, irrespective of technology, it becomes harder and harder to interpret. Now, once again, this is kind of...
You're saying people shouldn't be keeping data forever?
Well, once again, it really depends on, what the records managers say and what the business decision is. I think that we're moving towards an environment where data is stored for longer and longer periods. So if you look at, just my home country of Australia, that, Australia passed laws just recently that require all ISPs or internet service providers to retain all of their customer connection data for a 2-year period. So basically every TCP/IP outbound connection or inbound connection they're logging, and every website that someone visits, they're logging. And it's kind of Big Brother, pretty scary stuff. But the ISPs do this anyway. It's a gold mine of information for them to be recording where everybody's going. Now, the government introduced these laws, and all of a sudden, everybody realized that they had to start archiving off, for just compliance purposes with the law, all of that data, 22 million Australians, all of their cell phones, all of their tablets, all of their PCs, those ISPs now have to retain all of that information of, what websites they're viewing for 2 years. Now, it's inevitable that the government are going to extend that 2 years to 5 years or 10 years. And, if the ISPs start finding uses for that data, or society starts finding uses for that data, you could find that all of a sudden that's retained forever. So, a lot of companies at the moment are going through the process, or, a lot of the people I deal with are going through the process of starting to go through their backup tapes from 10 years ago and start destroying them. So they're putting, records management processes in place.
But you did bring up a very interesting point of, maintaining, all this data, requirement to maintain data for 2 years, all the TCP/IP connections. And then the ISPs at some point go, well, maybe this data is valuable. Well, now you're rolling into what people consider big data. And, when you're talking big data, you want that data online and available so you can run through different analytics to be able to pull out the patterns that they're looking for to make that data useful. And to me, that all resides on disk.
Well, interestingly, I talk a lot with the tape drive engineers. The tape drive technology has a lot of functionality in it that is just basically latent, waiting there to be exploited by people. So at the moment, tape drives have technology in them that allow you to search data without transferring the data from the tape drive to a position where the CPU can analyze it. So right now today, if someone wanted to leverage this technology, you can say to a tape drive, I want you to go and I want you to find these strings of data on the tape. And the tape drive will go off of its own accord and read through the whole tape until it finds those strings, and then come back and say, I've found something. Now that becomes really fast because the data is streaming off the tape. When you don't know what you're looking for, if you've got a large disk array and you don't know what you're looking for, there's a huge amount of seek time that goes on. It's basically a sequential read, but it's a sequential read that requires seeks to go from track to track on the disk. Now, if you leverage that technology on the tape, you can say, hey tape drive, I want you to mount this tape, and I want you to tell me whether or not this tape contains this string. Now, if the tape drive comes back and says, actually, I searched the whole tape and I didn't find that string, the engineers are telling me that tape is at least 4 times faster than disk to do that search. And the reason is that you're offloading the search to the device, which you can do with the one-to-many implementation of tape. So what you can do is, the reason that an LTO tape drive is $3,000 is because that LTO tape drive contains a huge amount of technology, a lot of technology that often isn't even used. For instance, encryption. With a tape drive, you can stream data unencrypted to the tape drive, and the tape drive itself will do all of the work of encrypting, and then when you're reading it back, decrypting that data. There's no CPU involved, and... Sure.
I mean, obviously, we have self-encrypting drives. So.
Yes, but it's not common to have self-encrypting drives. So everyone who has an LTO tape drive, so, a good 80% of the people, and now I'm just picking 80% as a random figure here because I don't really know, but let's say 80% of the people out there use LTO technology. Well, LTO technology from LTO 4 or 5 on had encryption built into it. So everyone who's got an LTO 6 drive already has the means to do encryption. and they have the means to do encryption on a one-to-many basis. So when they buy 1,000 tapes, each one of those tapes doesn't have to have encryption capabilities in it. Only the tape drive has to have that encryption technology. Now, the majority of people who have disk drives don't have self-encrypting disk drives. And if they do, every time they have to buy a disk drive, they have to buy a self-encrypting disk drive, and they have to pay that extra money to get that technology built into the drive. So, once again, I can tell you, everyone who has an LTO tape drive, LTO5 tape drive right now or above, they got encryption. They got encryption for every single one of their tapes. If they got one drive and they got 1,000 tapes, they're completely covered with encryption. But it's quite uncommon for companies to have self-encrypting drives completely through their enterprise.
Well, and guys, I'm going to have to ring the bell on this one and definitely say that we are more than likely due for a rematch here. So we're kind of up against the window of time here. I like to keep the episodes within a certain time period. I really enjoyed having both of you on the show. Look forward to bringing both of you back. And this will conclude this episode 22 of Data Protection Gumbo. Thanks for coming on the show.
Thank you.
Well, thank you.
Bye.
Bye.
I want to thank you for listening. I welcome your feedback on iTunes and ask that you provide a rating and share with your peers. Please follow me on Twitter at dmalbro and connect with me on LinkedIn. Together, we will be able to add to the innovation of storing data more efficiently and smarter. Have a great week.